Hello everybody, this video is section 3.4, logical arguments. A logical argument is made up of two parts. The first part is a premise or premises. And the second part is a conclusion based on those premises. Now, an argument is valid if the conclusion necessarily follows from the premises, and invalid if it is not valid. An error in reasoning that leads to an invalid argument is known as a fallacy. So let's notice that our definition of valid doesn't use the word true. Because remember, logic is not about deciding if a claim is true. It's about deciding if the claim can be deducted from the premise. So step one, when determining the validity of an argument using the truth table method, is to write the argument in symbols. Now, writing an argument in symbols would just be like what we've been doing where we write things as P or Q's or R's with our connectives and negations. The second thing we want to do is we want to write the argument as a conditional statement. So remember, conditional is our if-then. And we're going to use a conjunction between all premises and the implication for the conclusion. So remember, a conjunction is and. Now our third step is to set up and construct a truth table. So underneath we have like the basic setup of a truth table here. We have symbols. This is where we would have all of our columns with all of the parts we would need to get the information for our last column. So this would be a P column, a Q column, potentially an R column, or some negations, connectives, etc. But in our last column, we're always going to have the conjunction of our premises inside of a conditional statement leading to our conclusion. All right, step 4, if all truth values under the conditional are true, that is that the statement in the last column is a tautology. Remember that from section 3? If the column you're looking at is all truths, then that would make it a tautology. That's going to be the case where we consider our argument to be valid. If we do not have all truths in our last column, we'll call the argument invalid. Let's look at an example. Determine if the following argument is valid or invalid. Okay, so we have these three parts. Part 1. If the ad campaign is a success, the marketing manager won't lose her job. Part 2. The marketing manager lost her job. Part 3. Therefore, the ad campaign wasn't a success. So think of this part 1 as our first premise, part 2 as our second premise, and part 3 as our conclusion. Well, the first thing we want to do is we want to write this argument in symbols. So I need to figure out what I want P and Q to be. Let's look at P. I'm going to choose to let P be the ad campaign is a success. So notice I see part P right here. I also kind of see part P right here, but it's like the opposite, which makes me think that I'm going to be talking about not P. Now I get to pick Q. I'm going to let Q be the marketing manager loses her job. All right, so when I look up at each of my premises, I kind of see something like Q right here, except it's that she won't lose her job, which makes me think not Q, versus in part 2, the marketing manager lost her job is basically exactly what Q says, so this would be Q. If I want to translate this into symbols, I basically have if P, then not Q. In this one, I just have Q. And on the bottom, I have not P. So how I would write that is if P, then not Q. Underneath that, I'm going to write my second premise, which is Q. Then I'm going to draw a line, and I'm going to draw these 3 dots in a triangle, and what that means is therefore, just like I have here. So those 3 dots mean therefore, not P. In words, what I just wrote was premise 1 over premise 2 therefore conclusion. So step 2, I want to write this as a conditional and a conjunction. So it basically says if premise 1 and premise 2, then conclusion. In symbols, this would look like premise 1 and premise 2, then conclusion. And to kind of indicate what I want to do first, even though we have our hierarchy of connectives, it's always helpful to have parentheses. So I'm actually going to put this first section in brackets to show that the if-then conditional statement is this entire part as our first part and just the not P as our second part. Now I want to construct a truth table for this. And again, I didn't put the brackets in our packet, but you can add them in if that helps you. Okay, let's construct our truth table. So when I look at all the different parts, I know for sure I need a P and I need a Q. I also have a not P and I have a not Q. Then on the innermost parentheses, I have this conditional with P and not Q. Moving out of those parentheses, I see that I have this conjunction. And then I have my entire statement with this outer conditional. So here's the basic setup of my truth table. I'm going to fill out the first 4 columns real quickly, and then we'll move on to the last 3. Okay, so I have the first 4 columns filled out. Now let's do our conditional with P and not Q. So from P to not Q, I have true to false, that's false. True to true, that's true. False to false, that's true. False to true, that's true. Now I'm going to be looking at the column I just completed and doing an and statement with Q. Again, if you have to highlight to figure out where you're at, that's totally fine. So I'm looking at these 2 right now. So remember, and statements are true when they're both true. So I have false, false, true, false. And then we're now on our very last column, which is looking at the previous column and doing an if-then over to not P. So again, I'm starting in the column we just finished, which is our big conjunction, and I'm doing an if then over to not P. We're reading our table backwards in this direction. Remember, the only time that the if then fails is if the premise is true and the conclusion is false. So over here the premise is false, so I already know true. Same logic. Here I'm going from true to true, so that one's okay. And on the last one, again, it starts with false, so I know it's going to be okay. Looking at my very last column, to determine if a argument is valid, I just need to see if I have a tautology. And since I have all t's, that implies I have a tautology. So since all the values under the conditional are true, I have a tautology, and the argument is valid. Again, because I found that the argument is valid, it implies that my two premises, if the ad campaign is a success, the marketing manager won't lose her job, as well as the marketing manager lost her job, together can imply that the ad campaign wasn't a success. This conclusion can be deducted from these premises. All right, here's another one. So determine the validity of the following argument. Emerging research shows that if cancer patients undergo aromatherapy, depression is lessened. One of my cancer patients is reporting a decrease in depression, so she must have undergone aromatherapy. So I wrote down what P and Q could be. So I chose P to be a cancer patient undergoes aromatherapy, and I wrote Q as the patient suffers less from depression. Again, you could pick these different, like maybe you wanted P to be a cancer patient does not undergo aromatherapy. That's okay. You're just going to have a different translation than I am, and you'll have a slightly different truth table. But as long as you're consistent with the way you chose P and Q, we should end up with the same answer for whether or not the argument is valid. But for this case, I thought it would be helpful if I just gave you P and Q. So I chose P, again, to be a cancer patient undergoes aromatherapy. I chose Q to be the patient suffers less from depression. What I would like you to do is to try to translate this argument into symbols. And if you want to do the entire 4 steps, that's totally fine. But at least start with trying to translate this right here into symbols. So you need to identify premise 1, premise 2, and your conclusion. So take a second to do that, and then check back in with the video. All right, our first premise is emerging research shows that if cancer patients undergo aromatherapy, then depression is lessened. Well, we let P be a cancer patient undergoes aromatherapy. So this basically says if P, then depression is lessened. That's our Q. So if P, then Q. Our second premise is one of my cancer patients is reporting a decrease in depression. So it sounds like Q is happening. There is a decrease in depression. So she must have undergone aromatherapy. The conclusion here is that she underwent aromatherapy, which was P. So the conclusion sounds like P. Translated into symbols, I have if P, then Q, and Q, therefore P. Step 2 is to write this as an implication. So premise 1 is if P, then Q, conjunction with Q. Remember, this is an if then, so if P, then Q, and Q, then P. All right, I already have the truth table set up for you, so again, take a second to try it on your own and then come back to the video and check your answers. All right, hopefully your table looks something like this. Just one thing I want to point out is this arrow right here. It's exactly the same as the arrow we normally draw, it's just a weird font. So hopefully that didn't trip you up too much. Other than that, hopefully you ended up with this column of true, true, false, true. So what we notice is that it's not all true. So this is not a tautology. Remember, our arguments are only valid if we have a tautology. So this means that our argument is invalid. So the argument is invalid since it is not a tautology. Or in other words, it cannot be concluded that the patient underwent aromatherapy. So remember, when we're doing an argument, we're trying to see if the conclusion can be deduced from the premises, and in this case, it could not. All right, some common valid arguments. So we just came up with our own premise, conclusion based off words, but there are some common ones that you might just start to recognize and know that if you did compute a truth table for them, it would come out being valid. The first one is called the law of detachment. And the law of detachment says if P, then Q, and P, therefore Q. Another valid argument is if P, then Q, and not Q, therefore not P. All right, there are also some common fallacies. So remember, fallacies are invalid arguments. The first one being the fallacy of the converse, which says if P, then Q, and Q, therefore P. Notice this fallacy of the converse is the same one that we just showed in our truth table, right? We had if P, then Q, and Q, therefore P, and we did our truth table to see that this was not valid. A second common fallacy is the fallacy of the inverse, which says if P, then Q, and not P, therefore not Q. And lastly, the fallacy of the inclusive, or. This is P or Q, and P, therefore not Q. So if you set up any of your arguments and you have a setup that matches one of these three, it should come back as invalid. But if you set up one of your arguments and it comes back as one of these two, you should know that your argument is going to be valid. All right, let's look at an example of some valid or invalid arguments. So part A, we have if P, then Q, and P, therefore Q. Well, if I go look back at the ones we just talked about, that's exactly the same as the law of detachment. So I expect this to be a valid argument. Let's look at part B. In part B, we have if not P, then not Q, and not Q, therefore not P. If I go back and look at some of the ones we just wrote, this looks very similar to the fallacy of the converse, but instead of using P's and Q's, I'm using not P's and not Q's. So since all of them match, like all of the P's became not P's and all of the Q's became not Q's, it's still technically the fallacy of the converse. So this would be an invalid argument. And again, this is the fallacy of the converse using not P and not Q. All right, you don't have to memorize all of these different arguments because remember, you could always set up a truth table, figure out the entire table, and look to see if the last column is a tautology or not. But if you do remember some of these, it'll just save you a lot of time. For example, doing your homework or just looking at an argument that you set up on one of your worksheets or whatever it is that we end up doing. So it's up to you. And I know we don't have a PowerPoint, but I did put in this lovely picture of a cat. I thought he looked like a lawyer. And we're talking about truth tables and logic, so I thought that seemed kind of lawyery. Anyways, enjoy this cat. That's the end of chapter 3. So good job, guys. You finished your first set of online lectures. Next, we're going to move on to chapter 10. See you then.